Hey guys, welcome back. Today we're going to talk through photometrics or site lighting design, and we have a document that gives a lot of standards and guidelines for how to do that. Kasey's going to walk us through that document, just kind of give you an overview of what to expect, information about types of lighting, information about typical requirements that we get, and then in a later video he's going to go through how to do the actual design. So in this photometric overview, let's listen to Kasey teach us about photometrics. Let's learn.
Welcome back everyone, this is Kasey. Today we're going to be going over the photometric design process and how to do photometric plans in Civil 3D and AGI 32. So we're going to start by going over our standard document which runs through the process and gives you typical standard information that's good to know before you start your photometric plan. So light levels in development are measured in foot candles. It's a pretty confusing unit, but 1 foot candle is equal to 1 lumen per square foot. The higher the foot candles, the more light in that area. So here we have some kind of standardized units for the amount of foot candles for certain types of developments. Things like car washes, restaurants, and commercial developments might require more foot candles than something like residential areas, and some jurisdictions, a lot of jurisdictions, have extra requirements on not polluting neighboring properties with light. If you have a commercial development which is bordering residential developments, you might be restricted on the amount of light that crosses the property line and onto the residential developments. No one wants bright lights shining through their window at night when they're trying to sleep, so that's a really common restriction that you might run into. But here we've just got some standardized or rough estimates of the amount of foot candles you're going to want to provide for certain types of developments. So the key general rule for doing photometric plans is we want to maximize efficiency. We want to provide the most light for the least amount of money. The first thing that you can do in order to achieve that goal is to avoid putting up light poles when not necessary. Light poles are very expensive. They're big, tall steel poles with these super big, expensive bulbs on them. So any chance that we can avoid putting up light poles, we want to take. So wall packs are the most efficient way to do that. They're the cheapest way of providing lighting because the building for that development is already there and you're simply attaching lights to the side of the building. So developments that are smaller and maybe have larger buildings on a smaller piece of land, so a lot of the space is taken up by the building itself, you might be able to get away with not providing any light poles and only providing light on the side of the building through wall packs. So another way that you can maximize efficiency is by the orientation of your light poles and your wall packs. So there's a handful of different bulb types. There's different configurations for light poles in which you can provide more light on one pole versus having multiple poles, right? It might be more efficient for you to have one pole with 4 separate bulbs on it that go in each direction, at 0 degrees, 180 degrees, 360 degrees, 270 degrees, as opposed to having 4 poles with only 1 bulb on them that all face different directions, right? Adding more lights onto one pole is far cheaper than adding more poles. So we'll touch on that a little bit later in the document. You can increase the height of poles in order to cover more ground with the light. So you may have a 25-foot pole or a 30-foot pole as opposed to a 20-foot pole if you need to spread out light in a farther distance. And we might provide higher lumen light fixtures. So more lumens means more light and more foot candles. Again, 1 foot candle is 1 lumen per square foot. So we might provide 42,000 lumen fixture as opposed to an 18,000 lumen fixture, and that'll provide much more light from one pole as opposed to adding another pole. So there's different patterns for different fixtures. Different fixtures throw light in different directions, so it's a pretty common thing that you might see the acronym FT, or meaning forward throw, meaning that the fixture throws light forward or in a specific direction and less light behind the fixture. Some fixtures like type 5 will throw light in a circular or square pattern evenly around the light in 360 degrees, as you can see here. So typically we specify lithonia lighting or visionaire lighting or LSI lighting. Those are the 3 fixtures that we use very commonly. I'm going to go ahead and open up this file explorer. So we have a ton of light fixtures or .ies files, which are compatible with AGI 32, saved under support, documentation, site lighting, fixtures, and IES. And we've got all these different companies and all these different fixtures provided. So we'll touch base on that again later. Here's another representation of the acronyms I was discussing before: type 1, 2, 3, 4, 5. Fixtures, forward throw fixtures, and the way that they throw light. So this red area is more light and the blue being less light. Here's a good list of some of the things we just went over, some of the common terms, right? Like LSI lighting fixtures provide a ton of different options for lumens. You can have 18,000 lumens, 24,000, 30,000, and so on up to 42,000 lumen. Light fixtures, again, using higher lumen light fixtures can be more efficient than lower lumen light fixtures, and it can be better to upgrade that fixture versus adding another pole to get light somewhere. But you do have to be careful. Some jurisdictions have maximum foot candles that you can provide for certain developments. You can't blind your tenants or users or your customers, so you can't just throw around 42,000 lumen lights all over the place in order to maximize efficiency. So it's a balance that has to be met between maximizing efficiency by minimizing the number of light poles and also not light polluting neighboring properties or providing a really extreme high number of light. The wall mount fixtures that we typically use are also provided by LSI Industries, and these are XWM or IES files that have the prefix XWM. And there's a handful of different meanings behind some of the numbers and stuff that are in the IES files, such as color, light, temperature, the color rendering, the light output type, being silicone versus some other sort of light output type. A lot of the information isn't necessarily relevant for our design purposes. What's most important is the number of lumens provided by that fixture. So once you get to this portion of the document, that's going to run through an entire step-by-step process of doing a photometric plan. You can use this pretty closely in order to do a photometric plan. It provides a lot of information, but we'll just run through it pretty quickly. AGI 32 is a very old software. At least the software that we use is a pretty old software, so it's only compatible with AutoCAD 2013 drawings. The newest format of AutoCAD DWG 2018 and newer, I believe, is not compatible with AGI 32. So all of your AutoCAD 2018 files have to be exported as AutoCAD 2013 files before they can be opened in the AGI program. So once you open those files in the AGI program and you import your AutoCAD files, you're going to want to import all the different objects that we typically import in a photometric plan, and we'll touch base on that again later. And then you're going to follow a pretty simple process. You're going to use the .ies fixtures that you specify in the AGI software, and you're going to place them around your site, and then it's going to calculate the foot candles at a ton of different points along the site once you define the area of the site. So you're going to draw and define your calculation point area, locate your IES fixtures. You're going to draw and define three-dimensional objects which block light, so specifically the building, and then some other objects can be drawn in, such as particularly tall fences that may be privacy fences. Obviously, chain link fences are going to let light straight through, but if you have a 10-foot tall privacy fence, that's definitely going to block light. Could help you out if you have a privacy fence along the backside of your property line between your commercial development and a residential development. So you'll want to make use of that. But typically you're only going to define the building as a three-dimensional object that blocks light. Okay, and then once you have all those things in place, you're going to run your calculation, and it's going to give you the foot candles all across the site. You can analyze them to see where you need more light, where you might need less light, and what needs to change before you finalize your photometric plan. And then you're going to export it back into AutoCAD, and then we're going to make our photometric P101 sheet so that we can finalize our photometric plan in AutoCAD.